This image is familiar to anyone who has flipped through brochures about the high-tech East or watched the news. The train's perfectly sleek nose cuts through blossoming cherry orchards against the backdrop of Mount Fuji. It seems like a triumph of the human mind over space, pure speed on the surface of the planet. We are sold a picture of a light, silent, and harmonious future. But this futuristic postcard has long since become a lie.
If you remove the advertising filter, you'll find that the future isn't gliding over the Earth, but digging into it.
Behind the promise of speed lies a story of monstrous violence against geology and tectonics. It is a story of punctured aquifers, radiation from deep rock, and tens of billions of dollars. This project is draining entire rivers. It is causing mountains to sink and prefectural budgets to burst at the seams from unforeseen expenses. Millions of cubic meters of dead rock are being brought to the surface to make room for a perfect void.
Technology created to conquer space has found itself trapped in a dark stone prison.
This is not just a transportation artery or yet another government infrastructure megaproject. It is an unprecedented physical experiment to alter the anatomy of the entire Japanese archipelago. The system that was supposed to become a lifeline has begun to devour the resources of its environment. The instrument of the nation's pride has turned into its heaviest and most unpredictable burden. At a time when speed still depended entirely on the rotation of a steel wheel on a rail, when the Earth's surface seemed the only possible arena for engineering battles and victories, when mountains were still an insurmountable barrier, not merely raw building material,
When Japan was just beginning to suffocate from a lack of space for its ambitions.
For its inhabitants, Japan has always been a prison of stone and water. Mountains cover more than 70% of the entire territory, leaving people only narrow coastal strips. The post-war economic boom demanded the immediate and massive movement of labor. The country needed a transportation system capable of connecting scattered industrial centers. The first Shinkansen bullet train was a brilliant compromise with the harsh landscape. Engineers did not attempt to cut through the mountains. Instead, they carefully skirted them along the coastline. The Tokaido Line became a symbol of rebirth, gracefully integrated into the island's complex geography. It was an unqualified triumph of the human mind, but its shelf life was limited from the start. A steel wheel rolling on a steel rail has a rigid and insurmountable physical limit. As speeds approach 300 kilometers per hour, physics becomes the enemy. Friction generates colossal temperatures, destructive vibrations, and microscopic cracks in the metal. The mechanical connection between the train and the ground becomes a source of constant danger. By the 1980s, the rails were literally groaning under the weight of ever-increasing traffic. The infrastructure was wearing out faster than repair crews could replace the damaged sections. Increasing speed was physically impossible without the risk of derailing the train. The system had reached the absolute limit inherent in the very nature of the wheel. In laboratories, people began discussing projects that had seemed like science fiction just yesterday. If mechanics had run its course, fundamental physics was to take its place.
Engineers realized that the only way to overcome friction was to eliminate its source.
The train had to break free from the ground forever. The idea of magnetic levitation was in the air, but its implementation required unimaginable power. Lifting hundreds of tons of metal and making them move smoothly was a task of monstrous complexity. Traditional electromagnets overheated and consumed more energy than the grid could provide. A breakthrough was needed, one capable of taming gravity. The realization of the wheel's limitations became a point of no return for all of Japanese engineering. A return to old technologies meant stagnation and economic defeat on the world stage. The decision was made at the highest level, turning the transportation problem into a national challenge. The state began preparing for a leap beyond the bounds of familiar reality. Thus ended the era of harmonious coexistence with the landscape. Engineers stopped viewing mountains as obstacles to be circumvented. Ahead loomed an era of ruthless conquest of space at any cost. The island trap had to be torn apart from within. Abandoning the wheel required the creation of a completely new environment for the train. Ordinary electricity was insufficient to tear the train away from the concrete trough. Engineers turned to superconductivity technology, which operated at the very limits of the laws of physics. This required the installation of cryogenic systems directly within the moving passenger car. Tanks of liquid helium, cooled to absolute zero, were installed deep within the train. At a temperature of minus 269 degrees, the metal lost its electrical resistance. Coils generated a magnetic field so dense that it literally repelled the multi-ton train. The train turned into a flying cryogenic capsule, surrounded by an invisible force field. At that moment, the vehicle ceased to be a train in the classical sense.
It turned into a horizontally falling projectile, clamped between powerful electromagnets.
Controlling such an object required a precision beyond human capability. Automatic systems now monitored every millimeter of the gap between the underside and the concrete. The illusion of flight came at the cost of a colossal complication of the entire onboard infrastructure. The maglev ceased to be simply a car with an engine and seats for passengers. It is an autonomous physical laboratory flying through space at tremendous speed. Any failure in the cooling system threatened an instant loss of levitation and a catastrophe. During tests at the Yamanashi test site, the train surpassed the 500-kilometer-per-hour mark. From the outside, it looked like magic, a massive mass gliding silently without any visible effort. Passengers inside barely felt any vibration as they sat in comfortable seats. But behind that silence lay the strain of millions of sensors and kilowatts of energy. To keep the vehicle in the air, the track infrastructure became an active element of the movement. It wasn't the train traveling along the rails, but the guide walls themselves that propelled it forward. A continuous chain of highly complex electromagnetic coils had to be laid along the entire route.
The track became one giant linear motor, stretching for hundreds of kilometers.
This meant an unprecedented cost per meter of the new track. The ground beneath the magnetic road had to be perfectly stable and level. Any ground subsidence threatened to disrupt the magnetic gap and cause a terrible crash into the concrete. Freedom from friction required total and strict control over the space. The illusion of lightness sold to the public was merely the tip of the iceberg. Hidden beneath it were heavy transformers, pumps, cooling units, and kilometers of cables. For a single car to appear weightless, thousands of tons of equipment had to operate at their limits. The body of the new system turned out to be incredibly massive and complex. The decision to sever contact with the ground gave rise to a paradox that the engineers realized too late. By severing its physical connection to the surface, the train became its absolute hostage. It could not turn, could not stop where a magnetic bed had not been prepared for it. Flight turned out to be the most rigid form of dependence. Levitation at speeds exceeding 500 kilometers per hour creates its own ruthless geometry. At such speeds, the concept of turning ceases to exist in principle. Any bend in the track generates centrifugal force capable of crushing the people inside the cabin. The laws of inertia turn the slightest turn of the steering wheel into a deadly thrill ride. Therefore, the old principles of laying tracks through valleys and along rivers became useless. Maglev demanded that a perfectly straight line be drawn on the map from Tokyo to Nagoya. Like a sniper's shot, the route was to ignore any natural obstacles.
Geography, which for centuries had dictated its terms to people, was doomed to destruction.
But standing directly in the path of this ideal line were the southern Japanese Alps. This is a massive wall of solid rock, cut through by deep gorges and tectonic faults. Bypassing them was impossible due to the loss of speed and increased travel time. The solution was as logical as it was insane: to tunnel straight through the mountains. The tyranny of the straight line forced the project underground for 86% of the route's length. The train of the future was doomed to become an ultra-high-speed, ultra-deep subway. The windows in the cars became a decorative vestige. For outside, there would be only eternal darkness. Passengers would pay for time with a loss of space and light. This route became an act of violence against the landscape, which does not forgive mistakes. The builders faced the task of laying tunnels at a depth of over 1,000 meters below the mountain surface. There, where the sun's rays have never penetrated, the rock pressure becomes unbearable. Humans were intruding into a zone that lived by its own million-year-old geological laws. The perfect straight line on the blueprint did not account for the chaos of the underground world. The Alps are not a monolithic block of granite, but a mosaic fractured by earthquakes. Layers of different rock types slide over one another, creating zones of deadly stress. By cutting into this massif, the engineers triggered a chain reaction of collapses. The rigid geometry of the route left the builders with no room to maneuver when faced with difficulties. If a sinkhole or soft ground appeared in the drill's path, there was no way to go around it.
They had to reinforce the voids, pour hundreds of tons of concrete, and stubbornly press forward.
The straight line became a dogma for which any resources were sacrificed. The cost of the straight line became apparent as early as the initial geological exploration drilling phase. To maintain the trajectory, optimal locations for shaft construction had to be ignored. The logistics of delivering equipment and removing excavated soil turned into a logistical nightmare for contractors. The route began to dictate its terms to entire regions. Speed demanded complete isolation from the natural human habitat. The train became a ghost that would rush beneath the feet of entire prefectures, leaving no trace. The tyranny of the straight line finally transformed transportation into an instrument of geological, surgical intervention. Digging deep tunnels is always a war of attrition against the planet's pressure. But drilling hundreds of kilometers through the Japanese Alps became a war of total annihilation against the rock. Huge tunnel-boring machines, the size of a multi-story building, roared as they gnawed into the solid rock. Metal cutters wore down against the granite in a matter of days, requiring constant replacement in the darkness. The interior of the Alps proved more treacherous than even the most pessimistic geological reports had suggested. The pressure from the mountain massif above reached thousands of tons per square meter of the vault. No sooner had the tunnel-boring machine managed to excavate the soil than the rock began to compress with a menacing crack. The concrete lining rings creaked, struggling to support the weight of an entire mountain. Zones of tectonic faults became a veritable curse for the construction crews underground. Solid granite suddenly gave way to fragmented rubble and sticky, deadly clay. Drills sank into voids, and the roof caved in, burying expensive equipment to death. Every meter advanced in such zones was won at the cost of incredible effort and risk. Engineers had to literally freeze the soil with liquid nitrogen to get through the loose sections. This artificial permafrost temporarily froze the rock in place, allowing them to install concrete reinforcement. But this was only a temporary solution, creating new problems with the tunnel's heat exchange. The mountain did not tolerate foreign interference and tried to push out or crush the concrete tube. The process of cutting into the rock was accompanied by the production of mountains of construction debris. Every minute, conveyors spat tons of dead, ground-up rock onto the surface. This rock, extracted from a depth of a kilometer, was unsuitable for either construction or agriculture. It turned into toxic waste that had to be disposed of somewhere. Quiet mountain valleys quickly began to be covered by gigantic artificial spoil heaps. Dust from the dump trucks obscured the sky, and the roar of the crushers shattered the silence of the protected forests. The logistics of removing the soil proved to be no less of a challenge than the underground drilling itself. The infrastructure of destruction swallowed up the landscape at a terrifying pace. Underground, the work turned into a monotonous, exhausting struggle for survival. The temperature of the rock deep underground rose, causing workers to suffocate in the humid heat. Ventilation pipes could not supply fresh air over such vast distances. People worked at the limits of their physical capabilities, operating machinery of immense power. The scale of destruction required to create a perfect cylindrical space was staggering. To build a track for the ultralight train, entire mountain ranges had to be moved in crushed form. The Earth gave up its very core to satisfy humanity's craving for illusory speed. This wound on the island's body will never heal. As they bored through the tunnel, the engineers thought they had overcome the worst obstacle, the hardness of the rock. But the true threat lay not in the stone, but in the voids between it. The mountain was preparing its main and most destructive blow from within. The deepest wounds inflicted on the mountains were completely invisible from the surface. For centuries, the Alps had stored colossal volumes of fresh artesian water in their depths. Underground reservoirs and hidden rivers had sustained the ecosystems of entire prefectures for millennia. The tunneling shields, making no distinctions, mercilessly tore through these ancient waterways. Water under monstrous pressure began to burst into the artificial concrete shafts, The maglev tunnels suddenly turned into giant, uncontrollable drainage pipes. They began to suck in groundwater, altering the hydrological map of the entire region. The mountain began to literally bleed, draining its reserves into the concrete channel. A crisis erupted in Shizuoka Prefecture, whose farmland depended on the Ogawa River. The river's water level began to drop catastrophically as the drillers advanced deep underground. The famous tea plantations, the pride of the region, faced the real threat of drying up completely. The ecological disaster was a mathematical consequence of the physical breach in the mountain. Local authorities sounded the alarm, halting work on their section of the route. A conflict of unprecedented scale arose. National ambitions versus the survival of a single prefecture. The railway company proposed pumping the water back to the surface, but the hydrogeology, formed over millions of years, could not be repaired with a plastic pipe. Attempts to seal the breaches with special sealants had only a temporary effect. Water always found a new crack in the pre-stressed concrete under the pressure of the rock. Builders had to create highly complex drainage systems directly beneath the maglev track. An artificial underground river now flowed beneath the high-speed train. This crisis exposed the project's central illusion, the idea that a mountain is simply dead rock. It turned out that the Alps are a living organism with its own circulatory system. By cutting into it, the engineers faced not just a technical problem, but a systemic failure. Nature resisted not with strength, but with fluidity. The cost of saving the Oigawa River placed a heavy burden on the entire construction budget. Additional work on waterproofing and water pumping consumed months of time and millions of dollars. But even these measures did not guarantee a full restoration of the region's historical water levels. A compromise was impossible. Either the train runs or the river flows. The environmental disaster in Shizuoka became a point of no return in the public perception of the project. The symbol of a technological future suddenly took on the image of a ruthless destroyer of nature. The hollow concrete pipe took away not only space, but also the very foundation of life. The mountain's severed arteries continued to bleed, demanding constant technical intervention. The water was merely the first warning that the enclosed space posed a threat. Once the engineers had dealt with the liquid, the power of compressed gas came crashing down on them. The air in the tunnels began to dictate its own deadly terms. The water problem paled in comparison to the aerodynamic nightmare created by the train in the confined space. A train hurtling into a narrow concrete tube at 500 kilometers per hour acts like a piston. It pushes a colossal wall of air in front of it, with nowhere for that air to go. The tunnel turns into a giant pneumatic barrel, ready to burst from internal pressure. This massive air in front of the train begins to compress, forming a microbaric wave. The wave races through the tunnel at the speed of sound, outpacing the maglev itself. When this dense wall of compressed air reaches the exit from underground, disaster strikes. The air bursts outward with a deafening sonic boom, reminiscent of an artillery shell exploding. The sonic boom is capable of shattering windows in homes several kilometers away from the portal. The blast is accompanied by a sharp pressure surge that disrupts the ecology of the surrounding valleys. For densely populated Japan, such a noise level was absolutely unacceptable and illegal. Hypersonic speed became a hostage to its own aerodynamic wake in an enclosed space. To dampen this pneumatic explosion, engineers had to resort to radical measures. The train's nose cone was stretched into a ridiculous, incredibly long 20-meter beak. This strange shape was dictated not by aesthetics, but by the harsh mathematics of air dispersion. The beautiful image of the train of the future was marred by the necessity of pushing aside the dense underground atmosphere. The aerodynamic shock created extreme loads not only on the portals, but also on the train itself. The car bodies were subjected to enormous stress from friction against the compressed air. Inside the pressurized cabin, passengers risked barotrauma to their ears when two trains passed underground. Every train crossing generated shock waves of unprecedented power. To prevent passengers from losing consciousness due to pressure changes, the car bodies were made absolutely rigid. Maglev cars resembled the fuselages of space shuttles more than conventional railway designs. They became heavier due to the reinforced frame, which required even more powerful magnets for levitation. Solving one physical problem instantly created a new one, making the system heavier. High speeds in the tube created yet another side effect. monstrous heat generation. Air compression heated the concrete tunnel walls to temperatures that destroyed the cables. The ventilation system designed to remove this heat consumed megawatts of energy continuously. The underground corridor turned into a scorching oven requiring constant cooling. The project, conceived for the sake of lightness and speed, became bogged down in a struggle against the density of gases. It turned out that the emptiness in the tunnel was an illusion. Air is material and unforgiving. It took revenge for the intrusion, demanding millions in cost to neutralize it. The illusion of flight shattered against an invisible yet palpable wall of atmospheric pressure. Digging deep underground to extreme depths has uncovered ancient secrets that have lain dormant for millions of years. The tectonic plates forming the Japanese Alps turned out to be not just rock, but a chemical reservoir. The granite massifs contain natural deposits of uranium and other heavy metals. By breaking up these layers with drills, the builders unleashed an invisible enemy. The ventilation systems, already overloaded, had to be upgraded to filter out toxic isotopes. Work crews donned protective suits, transforming into accident cleanup crews. Time spent underground was strictly regulated, further delaying the already behind-schedule project. The mountain resisted the intrusion at the atomic level, poisoning the air. But radon was only part of the chemical nightmare awaiting the engineers deep underground. Millions of tons of rock extracted to the surface turned out to be contaminated with natural arsenic and lead. This toxic soil could not be used to fill ravines or build dams. A massive volume of soil was classified as hazardous waste requiring special disposal. To isolate the toxic rubble, gigantic sealed burial sites had to be built far from rivers. Their bottoms were lined with special membranes to prevent toxins from seeping into the groundwater. The logistics of moving the contaminated rock required the creation of a separate fleet of specialized dump trucks. The railway project became entangled with chemical weapons disposal infrastructure. The darkness of the deep tunnels hid the scale of this environmental disaster from public view. At press conferences, they showed clean white rail cars, keeping silent about the toxic waste dumps in the mountains. Workers emerging into the light after their shifts underwent a strict decontamination procedure. The future of speed was being built under conditions of chemical siege. Even after construction is complete, the problem of toxic waste will not disappear. Isolated burial sites will require monitoring for decades, draining local budgets. A single drop of water seeping through the protective barrier is capable of poisoning entire agricultural regions. The soil excavated to create a void has become an eternal curse for the surface. This invisible front of work revealed just how deeply the system has encroached upon nature's fundamental balance. The Earth defended itself against mechanical violence with its ancient toxic chemistry. Every meter of rock penetrated was paid for not only in yen, but also in the health of the ecosystem. The darkness of the tunnel turned out to be filled with threats unrelated to transportation. In attempting to create the ideal environment for the train, humans destroyed the natural environment around them. Conquering the mountains turned into the necessity of managing millions of tons of poison matter. The symbol of technological superiority turned out to be inextricably tied to dumps of radioactive granite. What was presented as soaring lightness required the creation of the most massive infrastructure in the world. The maglev train itself truly flies, touching no rails, outwitting gravity with speed. But to maintain this illusion of weightlessness, the tunnel walls must bear a monstrous load. The magnetic coils installed along the entire length of the route weigh millions of tons. The track infrastructure has turned into a giant, heavy exoskeleton encased in a concrete tube. The energy required for levitation necessitates the construction of an entire network of underground power substations. The size of small factories, they are hidden in enormous caverns carved out of granite. Transformers hum in the darkness, processing electricity equivalent to the consumption of an entire metropolis. To ensure safety, the redundancy system has been taken to the point of absolute paranoia. Every cable, every sensor, and every pump is duplicated, doubling the weight of the structure. If one substation goes offline, the neighboring ones must instantly take over the load. This redundancy has made the system incredibly expensive to maintain and physically unwieldy. The underground stations along the route are striking in their overwhelming, colossal scale. These are not just platforms, but veritable underground cities buried 100 meters deep. To descend to the train, passengers must use high-speed elevators and escalators. The architecture of these stations is dictated not by comfort, but by soil pressure and evacuation standards. Paradoxically, the weight of this infrastructure robs the project of any flexibility. It is impossible to modernize a maglev in stages, like a conventional railway. Replacing a single generation of magnets would require rebuilding hundreds of kilometers of track walls. The system is frozen in its ideal form, incapable of inexpensive evolution. The illusion of flight is sustained by the efforts of thousands of people operating pumps and servers. While the train hovers in a magnetic field, heavy, dirty work by technicians is underway underground. They battle against moisture seepage, contact corrosion, and ground subsidence. This invisible labor sustains the glossy image of a technological marvel on the surface. Every kilogram of weight shed by a car becomes a concrete burden on the tunnel. The train's lightness is paid for by the static weight of the mountains, transformed into a foundation for the magnets. This inverted physics makes the project a hostage to its own massiveness. The faster the flight, the deeper and heavier the anchors must be buried. The system has become too cumbersome to tolerate even the slightest error. The failure of a single element is capable of destroying the fragile balance of the magnetic gap at tremendous speed. The weight of the illusion proved so great that it began to drag the entire country's economy down. The physical resistance of the mountain inevitably transformed into a crushing financial collapse. The initial budget of $50 billion had been calculated for the sterile, paper world of engineers. When the drills encountered real water, gas, and faults, the numbers began to grow exponentially. The estimate quickly surpassed $70 billion, and that was far from the limit. The construction timeline turned out to be just as much of an illusion as the investors' smooth schedules. Delays caused by flooding and disputes with prefectures stretched out over long, agonizing years. The project shattered political promises and pushed the launch date beyond the planning horizon. Every day of equipment downtime, deep underground, burned through millions of budget and corporate yen. The worst part is that construction cannot be stopped or put on hold until better times. Abandoned tunnels will quickly fill with water, and concrete left unmaintained will crumble under the pressure of the mountains. Huge sums are already buried in granite, and to justify them, even more must be spent. The government has fallen into the classic trap of escalating commitments to a megaproject. The rising cost will inevitably be reflected in ticket prices for end users. To recoup hundreds of billions, the maglev must operate at full capacity for decades. But Japan's demographics are inexorable. The population is aging and shrinking, reducing demand for travel. The train of the future risks running empty on the most expensive tracks in human history. To find the money, the company is forced to cut spending on maintaining the old Shinkansen lines. Traditional infrastructure is beginning to suffer from underfunding for the sake of this underground monster. The maglev is sucking the financial lifeblood out of the very networks it was supposed to relieve. The system is devouring itself to give birth to this wonder weapon of speed. The project's economic gravity is even distorting the country's regional development. Stops are not planned everywhere, and cities without maglev stations are doomed to decline. Capital and human resources are drawn to gigantic underground hubs, bleeding the provinces dry. The project, conceived to unite the nation, harshly divides it into winners and losers. Politicians have become hostages to ribbon-cutting ceremonies and buried trillions. Admitting the project was a mistake is tantamount to political suicide and national disgrace. That is why money continues to be pumped into underground shafts with the stubbornness of the doomed. The gravity of debt proves stronger than the gravity of the earth the train was trying to overcome. Maglev has not yet carried a single commercial passenger, but it has already crippled budgets. It is a monument to how the ease of movement is paid for by the incredible weight of capital. Today, the Tohoku Shinkansen project is no longer merely an initiative to modernize the railways. It has mutated into an irreversible geological, economic, and social process on a national scale. Tunnels have already been bored through the rock. Their reinforced concrete arches have forever altered the tectonics of the Alps. There is no going back to the era of compromised routes and surface tracks. Driven by an absolute thirst for speed, Japan has condemned itself to an underground future. This monumental infrastructure has become so deeply embedded in the island's body that it cannot be dismantled. If the trains stop, the tunnels will remain as scars in the planet's depths until the end of time. We are witnessing the construction of the most enduring monument to human hubris in the 21st century. The mastery over space promised by the maglev has turned out to be a costly illusion. The system survives only thanks to continuous, massive injections of capital, energy, and human labor. This is a new form of fragility, where the failure of a single transformer paralyzes the nation's mobility. The absolute rigidity of the straight line left no room for adaptation or maneuver. What began as an elegant solution to the problem of friction has turned into an underground sarcophagus. Form has triumphed over function, forcing an entire country to work to maintain an empty pipe encased in granite. We marvel at the technology of levitation, forgetting the violence hidden behind its facade. The triumph of engineering always leaves scorched or hollowed-out earth in its wake. When the first passenger train finally races through the Alps, it will be a celebration. Politicians will smile for the cameras, and announcers will praise the speed of 500 kilometers per hour. No one will see the disfigured landscape through the windows, because behind the glass there will be nothing but a concrete wall. The perfect mode of transport for a society that prefers not to look at the price of its comfort. This structure of the transportation system will not collapse from wind or fire. It will stand, withstanding the pressure of the mountains, as long as there is electricity in the wires. But it has already taken the island's water, money, and silence, demanding ever new sacrifices. The architecture of inevitability is complete. To fly, we have voluntarily buried ourselves underground. Take another look at this familiar, sleek image of a Japanese train from the future. At the perfectly smooth capsule, hovering above the ground, flying faster than the speed of sound. What you see is not technology. What you see is the most expensive mask in human history. Beneath this gleaming aerodynamic shell lies a brutal, dug-up, water-soaked reality. The desire to break free from the shackles of friction has led us to a collision with the very core of the planet. Maglev is a story about how an attempt to cheat nature turns into total dependence on its whims. We wanted lightness, but we got an infrastructure weighing millions of tons of toxic concrete. We wanted to conquer space, but we voluntarily locked ourselves in a blind underground tunnel. This project stands not because levitation is a natural step in the evolution of transportation. It stands only because national pride and the fear of falling behind prevent it from collapsing. The cost of this speed rises every day, with every new aquifer breached and every kilowatt burned. And this cost has long since exceeded any reasonable economic logic. Someday the mountains will have their revenge, closing their tectonic jaws around the concrete tubes. But for now, the pumps are pumping water, the magnets are humming, and the illusion of flying through stone continues. The future is being built right now, and it smells of wet concrete, ozone, and vast sums of money. True speed always comes at the price of darkness.